In the class, please let me know about the recording also here. Okay, I'm just forgetting about the recording also. Okay, no problem. I'll share the previous class recordings if it's possible to me. Is it okay now?
Yes, sir.
Yeah. Yeah. Thing is like when you don't have this particular combination of a passive filter and just make it as a passive filter. A passive filter. Yeah, in that case, when you don't have this filter, the source is supplying this filter the fundamental current as well as the harmonic current. But when you use this a passive filter, this is going to, we design a passive filter to deliver the harmonic current, and the load is going to take that particular current also. Okay, the load is going to take the harmonic current as well as the fundamental current. Okay, this is about the source of the fundamental current. See, in this case, it is obvious like the load is going to take whatever it is demanded. Only thing is the source is not supplying. Okay, the source is not supplying. Okay, we are trying to make out a path of to a short. I mean, we are providing a path. What I'm exactly technically speaking, we are providing a short. The impedance offered with respect to the harmonic current is very low, rather than the impedance is offered with the source is very high. Okay. Okay, the passive filter is designed in such a way that a particular frequency component is providing the low impedance to flow that particular harmonic current. Okay. The point is here, it has no control over the currents. That's what I was mentioning also. Okay. Therefore, the standards in the power quality area are devoted to maintain the supply voltage within certain limits. Okay, within the certain limits also. Okay. Whereas with respect to the current, we have a limits also. We have some limits over there, but as such, it is not so. Okay, it is not so because I mean the voltage. If you specify certain limits, in that case only, if you specify the limits, in that case the manufacturer who will be manufacturing the equipment also will be designed to with respect to these particular limits also. Whereas the utility side also, there are having a control over the voltages, but not in the current. Current is very much demanded by the individual customer. Okay, that's what we have seen in the earlier point also. The same thing also is applicable. Consider the above point. Based on with respect to the above point only, we can say that the utilities have the only control over the voltage, but not the current also. Even like if suppose sometimes yeah, that is the point actually. Okay, we're not going to other points. Yeah. AC power systems are designed to operate the sinusoidal voltage at a given frequency and magnitude. Okay, at a given frequency and magnitude also. Any significant deviation in the waveform magnitude, frequency, or purity is a potential for power quality problem. Okay, we were going to see about the magnitude and then the frequency. Okay, these are the points with respect to the voltage, even with respect to the voltage in the single phase system. Okay, but when you go for a three-phase system, what we expected to be a balanced, balanced voltage. Okay, we expect to be a balanced voltage. It's not like that one phase is something having the magnitudes, having the rated magnitude, and then the phase difference is also to be expected to be a 120 degrees with each other also. That shows about the the balanced. Okay. Yeah, there are some points. Of course, there is always a close relation between the voltage and the current in a practical power systems. Okay. Yeah. How this? I mean, if you see the point number one, this particular point, the current resulting from a short circuit causes the voltage to sag or disappear to be a voltage also. When you see about, I mean, power quality, it is related to be a voltage quality, right? Ultimately, if you see one particular this particular point, the quality of the voltage is degrading because of the current, because of the current. Okay, because of the current. Any short circuit, occurrence, why people are continuously leaving and joining back again? The strength is 18, right? Why 21 students have been registered? Look, in anyone? Is there any PhD scholars are there?
Yes, sir.
Yeah, you are there. Apart from you, anyone? Okay, I'll try to verify in the WSDC portal.
Sir,
Okay.
you are 2 times, sir, login, sir. Yourself is
Uh-huh.
2 times, sir.
Yeah, okay, fine, fine.
Count it yourself. That's right.
No, 19 should be there, including you. I mean, there is 21 is there, but mine is showing double, but it should not be 21, it should be 20.
18 MTech, 1 PhD and 1.
Yeah, yeah, it should be 20, right?
Yes, sir.
Okay. I mean, have you verified with the WSTC this LMS, Moodle LMS, everyone? No, I'm not going to send you emails regarding any kind of the emails regarding the content. See, I shared in all in the Moodle itself only. You're all the you have been added in the participants also. Are you able to see that your numbers?
Yes, sir.
Do you got the access privileges or not? Do you got the access privileges or not, this Moodle?
Yes, sir, yes.
Okay,
Yes,
I mean, I'll be updating the content related over in the this Moodle only. Okay, I'm not going to send you any emails. Please follow this Moodle portal. Even I will update the lectures link also over here, everything. Okay. Yeah. I mean, if anyone are missing over here in the Moodle also, the participants is around 19 participants found. Okay, one more have been registered. Fine. Okay, yeah. Okay. Yeah. The current, when you see about the current, all the generators, if you see this particular point, all those generators may provide a near perfect sine wave voltage. The current passing through the impedance of the system can cause a variety of a disturbance to the voltage. Okay. Whereas generator is very far away from your distribution system, right? When you generating station is very far away from the distribution system, and yeah, the waveform which is there nearer to the distribution system is got polluted. Okay, with the currents because of the feeder impedance. That feeder impedance drop is affecting the voltage. I mean, here when you see here, yeah. Yeah. When you see a system having a feeder impedance over here, this is Vs and this is ZS. and this is the terminal voltage VT, and we have a fault over here. We have a fault over here. The IF is going to flow, and there is a load over here. Okay, that's what this particular point says about the current resulting for a short circuit cause the voltage to sag or disappear completely, as the case may be. If the fault is much more higher, then this particular voltage VT is going to have about a Vs minus of IF into Zs. Okay, if you neglect this particular current of a load is very smaller than this particular IF is much higher than this particular IL current, then the VT we are experiencing a zero voltage, maybe a zero voltage or maybe a sag. We'll come back to this particular definition what it is. For a time being, we just say that there is a reduction in the voltage magnitude, maybe a point less than the 0.9. Okay, less than the 0.9. Current from lightning strokes passing through the power system cause high impulse voltage. This particular point also we have seen it, that frequently flash over the insulation and lead to over the phenomena such as short circuits. Okay. And also this distorted currents from harmonic produces loads also distort the voltage as they pass through the system impedance. Thus a distorted voltage is presented to the other end users. Like if you see about okay, if there is a load which is of drawing about the harmonic current over here, then your VT also is going to have VT is equal to Vs minus of Zs into IL plus IH. Okay, IH. This VT is polluted with respect to the having the fundamental voltage magnitude reduction as well as the harmonics. See, but as such, like the source is not generating any harmonic current, but the source, but the current which is the current of the harmonic current is producing the harmonic voltage also. It's producing in the sense, if at all, if you want to draw that particular fifth harmonic current, that particular harmonic voltage to be generated. It's not like that it should not, there is no fifth harmonic voltage, but it should be. Okay, otherwise, if you don't have the fifth harmonic voltage, it cannot able to drive that particular harmonic current also. Okay. The distorted currents from harmonic producing loads also distort the voltage as they pass through the system. Thus, the distorted voltage is present in the other end users. Therefore, while it is the voltage with which we are ultimately concerned, we must also address the phenomena in the current to understand the basics of the many power quality problems. Okay, when you see these particular 3 points, looking over these particular 3 points, it is almost all the power quality issues which is going to come arise is because of the current. Okay, because of the current is driving this is influencing the voltage very much. Okay. Yeah, why are we concerned about the power quality? I just brief about some points. Okay, not all. Okay, one thing is there are some of the sensitive loads which are very much sensitive for even the variations in the voltage. As I was mentioning about some of the microprocessor or the DSP based controllers, they are very much works with the zero crossing or the clock frequency also. Okay, that kind of the things are there. Why I'm telling was the zero crossing. The zero crossing is a reference for the controllers, DSP based controllers or the microprocessor based controllers also. Why the zero crossing is going to change is I tell you, like, if there is any voltage variation, suppose this is the what we expect to be a sinusoidal. Suppose there might be change over here, okay, in the voltage. In that case, it is going to alter to this particular waveform. if there is any kind of a change which is going to occur over here. See, the zero crossing is going to set over here. With respect to change in the voltage, it is going to, the actual zero crossing has to start over here at this particular point. But because of the variations in the voltage, it is going to change from this particular point to this particular point. Okay, I mean, we'll see why this kind of the effect is going to come. One thing is because of the sag. Okay, we're going to have a phase shifts in the voltage also. We'll try to see these particular points. Okay, when the zero crossing has been changed, it is a very serious effect with respect to the controllers. Okay, and also these particular points, when you have any kind of a power electronic devices, power electronic device also very much are going to operate with reference to this zero crossing also, In that case, there is a malfunction of the equipment, and also especially the process industries. The process industries are very sensitive to the voltage variations. Because a certain point, process industries in the sense, if you take about a semiconductor manufacturing industries, I mean, almost all in the process industries, they have, for every kind of an operation, they have certain voltage limit or a threshold value of the voltage will be there. Suppose if there is any glitch in the voltage, or any kind of reduction in the voltage, in that case, all the process industry is going to shut off. I mean, it's going to shut down. And to restart it again, it involves the cost also. Okay, even like if you take about especially the operation theaters, some of the operation theaters, they are going to have some kind of a robotic kind of a things. So they use the operation also for the operation. Okay, for those things, if there is any voltage variations is there, that will be a serious problem. Okay, that will be a serious problem also. Even the over voltage also will be creating a very serious problem in the manufacturing industries, even in the hospitals, where they are very much where there is where in the hospitals where they use much about the electronic where they use more the technology. Okay, yeah, even this particular problem is a very old problem. There is clocks will be there. They are going to reset according to the disturbance which is going to occur in the power systems also. Yeah, this is a point which we have seen, like in the semiconductor manufacturing industry, the economic impacts as associated with the equipment sensitivity to momentary voltage sags resulted in the development of full use standards for equipment right through also. For the equipment, voltage right through. Okay. And because of that, we required to have the concern over the quality of the power supply. There is a point which is there of deregulation. Okay. With today's movement towards the deregulation and competition between utilities, they are more important than ever. The deregulation is in the power industries is restructuring the rules and economic incentives that government set up to control and drive the power industries. Okay, I mean incentives will be given to the end users or the power industries. Okay, especially I mean, this is like incentives will be given if they are maintaining the power factor, or if they are maintaining the voltage at the distribution level also. Okay. I'm just moving out of this particular content. Okay, I mean, most of this, the quality issues which are concerned with respect to the economic related problems with respect to the customers, and with respect to the utilities, they look over uh, the industries in order to not to have the very serious effect in their production also. Okay. Yeah, I'll just move to the power quality evaluation procedure. Okay. Power quality evaluation procedure is to give the appropriate solution to improve the quality of the power supplies. Okay, what kind of the solution will be provided to improve the quality of the power. In this class, I was mentioning about one of the case, right? Giving about the solution in the utility side, giving about the solution in the end user type. Okay, which one is appropriate and which one is economical. For that, to have the solutions for the different types of the power quality issues, what we need to do is you take about, yeah, before going to come to this particular content, I'll just give about some of the basic things or the fundamental things which you must know. Okay, when you are studying about the power quality codes. Okay, the power quality is power quality issues which we are going to study in this course is the problems are associated with the distribution systems, or the power quality issues which are associated with the distributions. We are not going to study the power quality issues which are associated with the transmission system. Okay, in general, in the transmission system, okay, we were not going to, there is no, I mean, there are no harmonics in the transmission side because the system itself makes not to I mean, the harmonics which have been there, which is not going to transmit to the transmission network also. Okay. Yeah. Why I'm telling us here, we have seen about utility transmission system and utility distribution system, right? Because of that reason, I'm just mentioning over here, whatever the power quality issues or the improvement which you are going to study with respect to the distribution system only. Okay, not with a transmission system. Okay. Coming back to this, the power quality evaluation or a solution also. You may be thinking that the solution can be given to a large scale industry. Okay, large scale industry. If you want to provide a solution for the power quality issues, what we require to have is we require to monitor the voltage or the currents of that particular industry. Okay, over a day or over a month. Okay, over a month also. And then we need to identify what kind of the issues have been uh, uh, have been there in the system also. Okay, is it a voltage sag, or is it a voltage regulation? Is it a voltage disturbance, or a flicker, or a transient, or a harmonic distortions? Once you identify, we need to see about the equipment impact. Equipment impact in the sense like, is it, if suppose there is a voltage imbalance, the concern to that, if there is a voltage imbalance existing in the industry locality, okay, is it affecting the voltage and voltage imbalance is affecting the system performance? That we need to know. Okay, We need to know about the equipment's impact with respect to sag or a flicker at a transition. If there is no impact on the equipment, then there is no point of giving about a solution or improvising or giving the solution or nullifying that particular problem also. Okay. We need to see, once you identify this particular problems, we need to know about the causes or the reasons why these kind of the problems are being occurred in the system. Okay, these causes of the systems. If you know the cause also, we can go think about the solution to the cause. Solution to this cause also. Suppose if there is a voltage imbalance, what is the appropriate solution which we can view it is, we'll see about is a voltage imbalance, is the problem is occurred in the upstream itself only. Upstream in the sense like, suppose this is a locality where our the industry loads are there, this particular. Is the voltage imbalance at the terminal is occurring because of these loads, or it is carrying forward in the upstream? Okay. If it is upstream, then we can't make it out also. We can make it out a balance. It's not like that we cannot make it out also. We need to identify what is the cause of it. Either it is the problem with respect to the loads, or it is the problem with the loads also. If it is a problem over here, in that case, what we need to distribute the loads maximum extent in the phase A in among the three phases. Okay, the voltage imbalance, if it is the case of voltage imbalance in the A base because of in this phase because of these loads, then we need to redistribute the loads, the single phase loads, such that the terminal voltage, the unbalance issue may not come across also. Okay. Even like in day-to-day life in our houses, also some of the cases where your AC may not be properly functioning also. In that case, what they do was, why the reason is maybe that phase is being overloaded also. Okay. Generally they do was they change over the whatever the AC connected to other phase also. Okay, because that particular phase has been loaded much, because of that the voltage has been come down also. Okay, they redistribute the loads also. I mean, what I mean to say, that important point is we need to see about the causes and we need to see about the equipment impacts. Okay. Okay, and then the characteristics also. The characteristics in the sense like, I'm not pretty sure about this particular point. What exactly we need to look over this particular characteristics. Okay, yeah. Next is to identify the ranges of solution. Okay, as I have been discussed, I've discussed in the just now. The solution may be the utility side, maybe the end user also. Okay, maybe the end user customer interface, maybe the end user system, maybe the equipment design also. Okay, there are if you come to the customer, there are three aspects. Customer interface is there, end user customer system is there, equipment design. The customer is having so many so many equipments also. Okay, is the problem which is raised is because of the equipment or because of the entire system, maybe the having the number of the loads, or the interface also, even like the utility distribution system. Okay, and after identifying the ranges of the solutions, okay, but not whereas in the power quality we are not going to give about the solution in the transmission system. Okay, when you are going to give about the solution in the transmission system, it is not so economical. Okay, because the transmission system is having a huge power, in order to provide the solution also. It involves a lot of cost and also technology which is going to be there. It is going to deal the huge amount of the power. Okay, in order to provide the solutions, what we require to design the entire system. Okay, design the entire system in simulation wise, and do the analysis. Do the analysis and say we can do the analysis what kind of the effect or what kind of the impact will be there on the performance, and the procedures also. Procedures in the sense like suppose if you take about a passive filter design itself only. Okay, a passive filter design is not so easy. Okay, it's suppose if there is a fifth harmonic current is more over in the system. If the fifth harmonic current, suppose as we seen that in this case, we have the fifth harmonic current demanded is more. To design particular fifth harmonic current, we need to undergo a lot of studies. We need to undergo a lot of studies and lot of analysis is required, mathematical analysis. It's not a very well, it can be done in a trial and error in a simulation. Okay. But practically when you're installing a passive filter, it is not very so easy. Once we go for a simulation and we need to do the lot of analysis, okay, then only we can go for the installation of the passive filter in real time. Okay, a passive filter in the real time. Okay, that's what, for that reason, we will have to model the entire system, do the analysis. After doing the analysis, it is like a step-by-step procedure is there. I'm just saying about the step-by-step procedure for the passive filter itself. Even like when you go for active power filters, or when you are going to provide any kind of a solution for especially for the transient also, it is not very so easy to provide the transient, the over voltage transient, which is going to come across because of the lightning or because of the capacitor banks. We need to evolve a certain kind of a procedure also. Okay, because there are some standards. Whatever we keep suppose if you take about an equipment itself, the equipment, if you see about the rating of the equipment, of the nameplate of the equipment, what they specify the voltage variations. It can withstand about 25% of the rated value also. Okay. In the same case, whenever you are providing any solutions, we have to look over whatever the other possibilities, other power quality issues, which is going to influence on this particular equipment. Okay. Okay. Suppose we have designed a capacitor bank. We have designed a capacitor bank to improve the power factor. Let's assume that we have designed a capacitor bank to improve the power factor. In that case, we need to see that capacitor itself only. If there is any over voltage or the lightning phenomena, this capacitor is capable to withstand that particular voltage variations for a shorter duration or not. For a shorter duration or not. Okay, is it able to withstand that particular lightning phenomena by this capacitor or not? Okay, why I'm telling was, I'm just mentioning about we have to have some kind of a methodology, a standard kind of the procedure is very well available in the literature. It's not just of providing a solution for particular problem. Okay, for a simulation it is not. It is okay. For a practical implementation, we require to have a modeling and we need to go for analysis. We need to go for the procedure, and then we need to evaluate the technical alternatives. Technical alternatives is it only one of the solution? Is there any other solution which is there also? Okay. Okay, another solution is there also. Okay, it is not like there is only one solution. See, I was just mentioning about the voltage unbalance. Voltage unbalance, I said like we need to distribute the loads in all the other phases also. There is a voltage regulators are there. Okay, there is a tap setting system is also there where we can change with the tap setting also. We can alter we can nullify the voltage unbalance also. Okay, with that I'm just highlighting that there are the different alternatives are there for a single power quality problem. After that, we need to come out of an optimal solution. It is a cost wise and it is a more it have the more reliable also. Okay, this about the power quality evaluation procedure. This particular figure I'm just giving about how we need to provide a solution to improve the quality of the power. Okay, don't think like this is the only the standard which is there also. It is not the is very well standard. Okay, it has been given in the Dugan test book. You might be going for any other kind of a solution. Only thing is like we need to look over the modeling and analysis and procedures and then the optimal solutions. Here I just want to highlight is if there is a power quality problem which is occurred in the distribution system level, okay, at the distribution system, then giving about the solution at the utility side is more economical. Suppose if it is a problem in the customer side, giving the solution at the customer is more economical rather than giving the solution problem at the utility side. What I mean to say that if it is a problem which is associated with the customer, give the solution at the customer's level itself only. Okay. Why I am telling that is if you go for attacking or nullifying the problem with the higher power level, okay, utility distribution level is much more, it is going to handle huge amount of the power and the voltage is also very much higher. In that case, the system power itself to handle the power quality issues is involving more cost also, the cost wise. Okay, it is not cost wise, it is huge amount which we need to invest to improve the quality of the power. Okay, giving about, I mean, if you look into the equipment side, if there is any power quality issues of occurring to the equipment side, then giving about the solution at the equipment level is much more cheaper than giving about the at the customer level also. Okay, that is a very important point which you need to think about of providing the solution to the equipment also. Okay, yeah. Yeah, these are the points. One point is which I missed, measurements will play an important role for almost any power quality concern. This is the primary method for characterizing the problem or the existing system that is being evaluated. In performing the measurement, it is important to record impacts of the power quality variations at the same time so that the problems can be correlated with the possible causes. Okay. Yeah. Solutions need to be evaluated using a system perspective, both the economics and then the technical limitations. Solutions that are not technically viable get thrown out and the rest of the alternatives are compared on economic basis. The optimal solution will depend on the type of the problem, the number of the end users being impacted and the possible solution. This is also one of the point is if there is a problem with the more the end users are affected, then we need to say at the customer side, even like if the more customers are affected to this particular issue, giving about the solution and the utility side is also appropriate. Okay, yeah, this about the evaluation procedure. In the next class we'll try to see about the different kind of a power quality terms. Okay, so far we have seen about the significance of power quality, why we need to concern, and now what kind of the solution, I mean not a what kind, we have seen about the evaluation procedure in giving about the power quality issues. In the next class we'll try to see about this particular terms, okay, power quality terms, and also some of the devices to suppress the over voltage. Okay, yeah. Have you accessed this Moodle? Anyone?
Yes, sir.
Okay. There is no difficulty, right? Even your minor examination also will be likely to be there in this particular module itself only. Okay. Yeah, I mean, all the links are whatever the links which have been there, which are authenticated. If you have any doubts, you can ask. I mean, it is not much more technical. It is like a theoretical only. I mean, much about the theory only. In the next coming units, you have a much about mathematical involvement is also there. But as such, like this unit also much about the definitions and standards are there also. Okay. There is no much problems which are involved in this particular unit. So please go through the textbook also, which I shared you over the Google Drive. Okay, you can read out the textbook also. Okay, then next class also, please. I mean, you all of you join with the same link. I'm not going to create the one more link. If there is any problem, I'll try to share you the Google link, but try to preserve this particular the link which have been provided today. Okay. Yeah. Okay then. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.